All right, good evening, everyone. I hope you can all hear me. It's Tuesday night, September 1st, 2020, time for a public night at the Leitner Observatory. And it's a nice, mostly clear night. I see a few clouds over in the southeast. Have a nice, bright, almost full moon. I think it's a day past full tonight. And although it's great to be back to doing the stream after taking a break to do some summer projects, we're still not open to the public. The building is not open to the public. Yale campus is not open to the public. But we're going to try to do these live streams for the public every Tuesday night. And when it's clear, set up cameras through telescopes, see what's up in the sky, tell you what's up in the sky when you go outside to look at the sky. And of course, take your questions. So I'm looking at the chat in YouTube. If anyone has any questions for me, happy to take questions. I'll swing my camera around here to point at the telescope in just a second, but getting a nice view of the sky over in the direction of the full moon tonight as we get started here. My name is Dr. Michael Faison. I am the director of the Leitner Observatory and Planetarium, and I teach astronomy at Yale. Classes have just started this week. Undergrads came back, and it's nice to be back in a university situation, even if we're not in classrooms and things are all kind of weird. It is a little bit of normalcy to have students to teach and to have projects to work on, and to feel the slightly crisp, cool evening air. You know, it's not cold by any means, but it's getting a little bit cooler at night, and of course that's very pleasant as we get into the fall and go out to observe. So what I'm going to do tonight is talk a little bit about what's up in the sky this week. So if you go outside on a clear night, any night this week, you can find some of the stars and constellations and planets that I'm going to point out. I'm not going to do a planetarium show tonight because it is clear, so spend most of the time on observing. I have two telescopes set up here, one with a camera and one without, and I'll swing those around. In fact, I'll go ahead and swing those around right now so that you can take a look at them. So I'll do a nice pan here across the horizon. There we are looking down at the I-95 bridge. There we are looking out at Farnham Gardens. Have a lot of people out having picnics today in the gardens. There you see my 90 millimeter refractor. This is my own telescope, which I usually have at home, but I brought it in to do some projects, and I was looking at the moon a little bit earlier. If I have time, I might put a camera on that and talk a little bit about what you can see through a small telescope like that, although I probably will run out of time, and we'll do that on another night. And then there you see the 12-inch Schmidt-Cassegrain telescope. It's one of the telescopes we use for our student labs. And there's where I was just sitting, running the computer that's running the stream and running the telescope. So let me point at both me and the telescope here. Good evening, everyone. Nice to see you. Hope some of the regulars for Tuesday night public night got the word that we're starting the live stream again, and some of you will tune in. Unfortunately, one of our super volunteers from Leitner Observatory, many of you who are regular visitors to the in-person public night that we've been doing for many years, know David Noble, who used to live in Wallingford, and he was one of our super volunteers. He would always come out on public night when it was clear to help point the telescopes and answer questions. And he actually just got a job at the Lowell Observatory Telescope out in Arizona and has moved out to Arizona. So we're really sorry to lose him, but also really happy that he's doing a fantastic job out there at the Discovery Channel Telescope. So Dave, if you're on the stream, congratulations on the job. Hope to see you in Connecticut or out in Arizona someday soon. Let's see, someone asked a question already. Let me see if I can read it here. How useful is the telescope for imaging planets in the inner solar system? Can you get good images of Venus, Mercury, or is the sun in the way? Yeah, it's a problem with any telescope that Venus and Mercury orbit inside the orbit of the Earth, And so you have to catch them either at sunset when the planet is on one side of the sun, or at sunrise when the planets are on the other side of the sun. Venus is super easy. Back in April or whenever it was I started doing the live stream, we had a nice western view of Venus right after sunset. And so we had a great view as Venus came around, went retrograde, went between us and the sun, and now you have to look for Venus in the morning sky. Mercury is harder because Mercury, the angle between Venus and the sun can get as big as 45 degrees. So if you point at the sun and point at Venus, the angle can be as big as 45 degrees. With Mercury, it's never bigger than 22 degrees. So Mercury can get lost in the haze down there. And it's also much fainter than Venus, so it's tough to see. I've seen it 2 or 3 or 4 times when I've made an effort to go look for it, and I know what I'm looking for, and it's great to do that. Put that in your your Audubon card that has the birds that you're watching, or your bucket list or whatever, is to catch Mercury along with the other planets. Oh, good. Dave, or Michelle and Dave are on the stream, so it's great. Hope you're settled in Flagstaff. I know it's beautiful out there and great place for astronomy, a mecca of astronomy. Whenever you go visit Arizona, all of you should go visit the Lowell Observatory. Very interesting for history. Of course, it's where the planet Pluto was discovered, but a lot of other important astronomy was done there, and it's just a stunningly beautiful location in northern Arizona. Okay, well, lots been going on this summer, so I'll try not to spend the whole live stream just talking about news and what's been going on at the observatory. We had our summer program for high school students, the Yale Summer Program in Astrophysics, remotely. We didn't have any students come up to the observatory to observe, but we had 46 students from around the world, 46 high school seniors, logging in remotely to use this telescope and to use the 16-inch telescope back here, and also some of the remote telescopes that we have access to monitor the brightness of 8 supernovae. And we came up with very nice measurements of the supernovae, and it actually worked out fairly well. I was kind of nervous about doing an online research program with a lot of high school students, but it was definitely worth doing. It was definitely rewarding. And yeah, I would do it again. I would definitely do it again. Something else, of course, that happened this past summer, those of you who are watching the live streams I was doing at the beginning of the summer, I started at the beginning of April when we had to shut down because of the pandemic. I was hunting comets. There were these predictions of some bright comets. There was Comet Atlas and Comet Swan, and as soon as they went around the sun, they disintegrated and were not that exciting. And so you probably heard about Comet Neowise this past summer, which I wouldn't say it was a great comet in the sort of with a capital G great comet like Hyakutake or Comet West or Comet McNaught or some of these historic great comets that you could really see with the naked eye and the tail was going across the sky. I looked for it many times here from the Leitner Observatory out in the parking lot after sunset. And eventually I saw it. So I'll show you a picture of Comet Neowise from the Leitner Observatory. So let me switch over to my browser here so you can see that. Yeah, so this is an image that I took. I forget the exact date. It was a few days after July 4th, I think. And I didn't use a telescope. I just had my Sony camera, the one I'm streaming with right now. I set it up on a tripod, pointed. First of all, I found the comet with binoculars, and then I set up the telescope and took, I think this was a 10-second exposure. So yeah, it shows the comet fairly well. I can zoom in maybe a little bit on it here so you can see what it looks like. So not a super bright comet, but we didn't have a great view of it here from New Haven. I've seen some photos, I'm sure you have as well, some photos from darker locations. Some of my colleagues who work out at observatories in the West or live in places where the sky is darker got some really nice images of the comet. But it was, humid here in New Haven, and the comet was always low in the west at sunset. It was really cool. No, don't get me wrong. I appreciated seeing the comet, and it was a lot of fun to see a good comet. But compared to Hale-Bopp, which was super bright, invisible high in the sky, NEO-wise didn't quite scratch that itch for me of having a super bright naked eye comet. So I'm still waiting for a good one, even though this was definitely satisfying. Let's see some other interesting astronomy news and things that have been going on. Something that I like to keep track of are near-Earth asteroids, and you may have heard in the news that we had a close flyby today. It actually happened a little bit earlier today. And where I go to look for news about sunspots and aurora and asteroid flybys and fireballs and things like that is spaceweather.com. So if you go take a look at this website, you can see right up here at the top, there's this asteroid 2011 ES4 flying through the Earth-Moon system, only 72,000 miles from Earth. So yeah, that's pretty close. That's like, about a third of the distance to the Moon, a little bit less than that, so very close. The space rock is 30 meters in diameter. So try to imagine that, right? 30 meters, like a third of a football field. That would be a bit bigger than the sort of observing deck here, maybe about as big as the building, the Leitner Observatory building. So if it hit the Earth, it would cause damage. And in fact, that was about the same size as the Chelyabinsk meteor that burned up in the atmosphere in 2013. There are a lot of great videos of this on YouTube because in Russia, apparently everyone has cameras in their cars. They have dash cams to record accidents and things like that. And so there's some really amazing footage that you can find online of the meteor, the fireball streaking across the sky and then exploding in the atmosphere, creating a shock wave. So didn't kill anyone, and there wasn't any serious damage, but there was a shock wave that shattered windows, and it certainly caused some damage. So yeah, the Chelyabinsk meteor, we didn't know it was coming, but this asteroid, 2011, the 2011 means it was discovered in 2011. We knew its orbit, and we could predict that it was going to fly by. And I was actually looking at this a little bit earlier, just how close it was. And this is the JPL small body browser that keeps track of asteroids and comets and things like that. And I'm going to zoom in on there's the orbit of the asteroid, right? So it's an Earth orbit crossing asteroid. And I'm going to zoom in here on the Earth. Okay. Yeah, there we go. So, and actually let's step forward in time a little bit. Yeah, so there you can see it flying by. And actually, if we sort of go to about now, this is more or less where it is. So it's already gone past, I think actually it's a little bit further. It's already gone past closest approach right now. I was thinking, is this actually a target that we could potentially look at with a telescope tonight if it stays clear enough? When it was closest, let me go back in time a little bit. So I had said a third, but it's maybe not quite a third of the distance from the Earth to the Moon. Sort of depends on what angle you're looking at. It's below the orbit of the Moon, so it's coming up and passing through underneath the orbit of the Moon as it goes by, and that's closest approach. And there are thousands of these objects that are flying by that we know about. If I wanted to see if I could see it from Leitner Observatory tonight, well, for one thing, it's in the direction of the Moon, and the Moon is right over there. So, where is it? It's sort of over in that part of the sky right now. So I could potentially, because the Moon is up, I could potentially go look around there for the asteroid. If I want to know the particular position of anything in the solar system, I use the JPL Horizons database, which I've shown on the live stream before. And I already put in the target I wanted to look at, the 2011 ES4. I'm observing from the Yale Observatory. I'm observing tonight. And these are kind of technical numbers for astronomers, but it's telling me where it is in the sky and how bright it is and how high above the horizon it is. And it gets bright, but not super bright, certainly not bright enough to see with the naked eye. And I'm not 100% sure that this camera that I have on the telescope right now would be sensitive enough to see it. I'm also not sure it's going to stay clear enough for me to see it. But I thought a little bit later on, when it's higher in the sky, I would give it a shot. If it's still clear and I'm still on the live stream, I'll keep the live stream going as I go look for it. But it may take a while, so you may get bored of that. It's not going to look like anything other than a point of light moving kind of fast relative to the background stars. And so that's kind of interesting. Let me tell you what I'm doing right now, and then I'll talk about what's up in the sky this week, and then we can look at a couple of other different objects. And if anyone has any requests for objects, or if anyone has any questions about what I'm doing or what I'm looking at, anything like that, I'm happy to take questions. So right now I have the telescope actually pointed at Jupiter. So if you look at the sky map for September, here, let's go download the September 2020 sky map. So this is a free service that skymaps.com provides. Very useful for observing naked eye or with telescopes, where you get a fisheye view of the whole sky, showing you what stars and constellations are out and what planets are out, and then a very nice calendar of upcoming interesting celestial events that are happening. So you can see here at about 9 p.m., that's about right now, in early September, here's the configuration of the sky. We've got the summer triangle directly overhead. We've got Jupiter and Saturn. Jupiter is the brightest thing in the sky after the moon. And then Saturn is actually not very bright, but I can definitely see it a little bit to the left of Jupiter when facing south. And then we've got Mars coming up over here in the east, right about now, although it's a bit low for me to see it. It's kind of behind the trees right now. In about an hour to an hour and a half, it'll be up above the trees, and I could potentially see it from here. I'll talk more about these stars and constellations here in a minute, but I do want to show you what I'm seeing of Jupiter through the telescope. So let me switch over to my view through the telescope. Here we go. So I have a little video camera on the back of the telescope right here. You might be able to see it there in the wide field. It looks like a little red cylinder, and I see some clouds going by, so might get more clouds coming through. Let me zoom out a little bit and adjust the brightness and contrast a little bit. So I pointed at this a little bit earlier and was adjusting the exposure and the focus a little bit. Yeah, that looks pretty good. Now, this is not the best view of Jupiter that I've seen by a long shot. In fact, I was observing last Sunday doing some tests for my observing lab class and got a much sharper image and video of Jupiter. But you can see some features. You can see the equatorial bands, and especially if you kind of wait and watch for when the atmosphere is momentarily steady, then you can see some more detail. And a little bit earlier, I saw the great red spot kind of over at the edge of the planet. And it may be that enough time has passed that Jupiter has rotated around so that you can no longer see the great red spot. Jupiter rotates very quickly. It rotates once every 10 hours. So if you're looking at Jupiter and you want to see the great red spot and you don't see it and it's sharp enough that you should be able to see it, you can wait 4 or 5 hours and Jupiter will rotate around so you can see the other side. Now, if I zoom out all the way, you can kind of see the field of view of this camera when it's on this 12-inch telescope, right? So Jupiter is really quite small, even when we're relatively close to it in the solar system like we are right now. It's not the closest, but it's relatively close to us. It's about 4.5 astronomical AU from us, where 1 AU is the distance from the Earth to the Sun. If I adjust the exposure, you can see the Galilean moons. So let me pump up the exposure. The Galilean moons are quite a bit fainter than Jupiter. When you look with your eyeball through the telescope, you can of course see this all at once because your eyeball has good dynamic range. The moons have moved around since I was looking at it about half an hour ago. So the moons are orbiting around the planet, which is, of course, the big thing that Galileo discovered. I'll zoom in just a little bit. So there's Jupiter. There was a moon over here. There's a moon, there's a moon, there's a moon. We'll go look up which moons are which here in a second. But this is kind of a fun thing that you could do if you have a small telescope. And my 90 millimeter telescope here, which is one, it's very affordable, can easily show the cloud bands on Jupiter and can easily show the Galilean moons. So you could potentially rediscover Galileo's discovery that these little stars orbit around Jupiter. These little stars, you know, these are terrestrial moons. They're large moons that are similar to Mercury and even in some ways similar to Titan and to Mars, even in some ways. They're all bigger than the Earth's moon, and Ganymede and Callisto are both bigger than the planet Mercury. So if these moons were orbiting the sun, we would call them planets in their own right. And you could see them with the naked eye. But because they're really close to Jupiter and orbiting around Jupiter, you need a telescope to see them to provide the magnification so that you can separate them out. If it is going to get cloudy, I do want to try to move over and look at Saturn also before we get clouded out. Doesn't look too bad yet. But let's see which moons these are. So I'm going to switch over to Stellarium. So remember, Stellarium is this simulation program that I've used a few times to show what's up in the night sky. And so I could talk about that a little bit now. So let's look at Jupiter and zoom in on Jupiter and hit the spacebar to keep Jupiter centered. And just keep zooming in. And so there you see, there's the planet Jupiter. And it looks like the red spot is kind of right on the edge of the planet right now. And then the moons are Io. There's another moon there called Amalthea. It's a very small, faint moon. You can see it under really ideal conditions with a big telescope. You can't see it normally. It's much, much smaller than the four big Galilean moons. So we've got Io, Europa, and Callisto. And I think the fourth moon, Ganymede, is behind Jupiter. If we were to go back in time a little bit, let's see if I can do that in the program. Oh, there it is. It just popped out. Oh, it must be an eclipse. That must be what's going on. So there's Io, Europa, and then there's Ganymede right there. Yeah, Ganymede. And Ganymede must be an eclipse right now. So that means that it's in the shadow of Jupiter. So again, if we let time pass. Oh, see, it blinked out. That would have been neat to see live. Let's see, when does it come out of eclipse? Here it comes, there it comes, there it comes. Oh, not before sunset. So we're actually seeing Jupiter at kind of 90 degrees to the sun. So we're kind of seeing it, if we saw a phase of Jupiter, we would see Jupiter kind of as a gibbous. But Jupiter's so far away compared to the sun that we don't really see that. So the shadow is kind of going off a little bit, sort of back into the left a little bit relative to us. So that's actually pretty cool. So the ones that we can see right now are Io, Europa, and Callisto. So let me go back to the live image. There we go. So this is live image from the 12-inch telescope at the Leitner Observatory going out over YouTube. So Io, Europa, and Callisto, and Ganymede is sort of right in there, and I can't see it at all. We'll zoom in on it again and get a view of the planet one more time. I am adjusting the exposure time of the camera, and then I'm also adjusting the gain, basically the amplifier for the video. All right. Well, if there are no objections, I'm going to move over to Saturn, which is just a little bit to the left or a little bit to the east relative to Jupiter. So if I show you this in Stellarium, okay, so let's zoom back out and see where Saturn is. Now I ran time ahead. Let me switch back to right now. So if you're in Stellarium and you hit the 8 key, it resets to current time. So there's Jupiter, there's Saturn, a little bit to the left and a little bit above a line from Jupiter to the Moon, and then we've got the Moon over there. So I'm going to move the telescope to Saturn. It should make a very small move to the left, and then we'll get it in focus and centered and see what we see. So I'm going to switch to the telescope control here, and I'm going to hide the video for just a second. I could do that. There we go. And so you can see the software that's actually controlling the telescope mount. So let me tell the telescope to go to Saturn. All right. So let's go over here and click on Saturn. And slew to move the telescope. There it goes. I can see it with my naked eye, so it's not completely clouded out. There I can see the summer triangle, which is basically overhead, so Vega, Deneb, and Altair. 3 bright stars you can see in the northern hemisphere all summer long. And let's get the camera image back in front. All right, so I don't see anything there, but we're going to have to sort of do some centering and exposure time adjustments and so forth. So let me first start by zooming out. And we'll do auto exposure. There's my old friend the raccoon is back. He just ran across the observing deck and under the gate over there. I saw him earlier in the summer, and then he went away for a while. But now he's back. Okay, so let's try to get Saturn centered here. Don't think it's clouds. Let me go to a longer exposure time. There it is. So there is some clouds that's dimming it a bit, but it's still definitely there. All right, so not a great view of Saturn because of atmospheric turbulence and clouds. So you see it coming and going there. And then, of course, when the cloud goes by, it gets wiped out. See if I can optimize this. Everything's very shimmery. You can see a few details, even though this is not a good image of Saturn. I see much better images from this observatory. You can see the shadow of Saturn on the rings. I can't see any of the gap in the rings, though. I mean, I guess if you've never seen Saturn before, maybe you're impressed with this image, but this is not that great. It's turbulent. It's a turbulent atmosphere, and the clouds are kind of coming and going. But there it is. Let's actually see if we can see any moons of Saturn. I think if it were clear, if it were unambiguously clear, we'd see probably 5 or 6 moons around Saturn. But because of the... Oh, there's one. So I don't know if you can see that right there. That is probably the brightest moon, Titan. Here, let's check with Stellarium and see if Titan is up there. We'll zoom in on Saturn here. Yeah, that's where Titan is. So you see in the orientation of the moon, there's Titan up there. If we had a nice clear sky, a nice steady sky, I think we're getting a gap in the clouds, so it may clear up enough to see that. Titan's up there. These moons, Rhea, Tethys, Dione, Mimas and Enceladus are hard to see, but Rhea, Tethys, Dione, Iapetus maybe. I don't see it out right now. There it is out there. Those are moons you would definitely be able to see with a telescope this big. Question, is this Harvard's astrology class? No, this is Yale's public outreach from the Leitner Observatory. We should have an astrology class. I mean, I talk about astrology in my archaeoastronomy class. Astrology is one of my favorite subjects. I could talk for hours and hours about astrology. I talk about astrology a little bit in my planets and stars class, and I talk about it more in my archaeoastronomy class. Astrology is fascinating. Oh, there goes the satellite. Don't know that I'd be able to see that, but there goes a satellite in the simulator right there. Let's see if Saturn's looking any better in the live view. Oh yeah, it's definitely looking better. Here, let me switch over. Okay, yeah, now I can see those moons. So there's Titan very clearly up there. Dione, Tethys, and I've already forgotten. Oh, this is Dione. Rhea, Dione, Tethys, Titan, which is the biggest moon, and then Iapetus is over there. Yeah, and I don't think I can see Mimas. Mimas is very faint. Mimas and Enceladus are the two smallest moons that are really close to the rings. And Enceladus is famous for having the ice geysers. Yeah, so someone's asking, Enceladus is icy, so why is it hard to see? It's really small. It's really, really small, and it's really close to the edge of the E ring. So if maybe we can get a better view of Saturn again now, if the clouds have passed by a little bit. Oh yeah, a little bit better view of Saturn and the rings. Of course, I have to adjust the exposure time and gain here because the dynamic range of the camera, what's the brightest thing you can see compared to the faintest thing you can see, is nowhere near as good as what you can see with your eye. So when you look through the telescope with your eye, you can see the surface features on Jupiter and you can see the moons. And when you look at Saturn, you can see the rings and the shadow and some of the moons. But the camera, it's just like high dynamic range cameras or high dynamic range televisions and so forth. You kind of have to play some tricks in order to see bright things and faint things at the same time. I don't know. I don't think Saturn looks significantly sharper, but I can see the shadow a little bit better. It's just not a very steady atmosphere tonight. There's something about the winds that are blowing and the turbulence arising from the city and so forth that makes it a little bit hard to see tonight. But Enceladus is pretty cool. I'm going to go back to the moon view here by raising the exposure time. Enceladus has these ice geysers. Enceladus would be sort of right in here somewhere. So I'm not. There's a little thing right there, but I'm not convinced that's. There's something there. Let me go back to Stellarium and see if that's where it's supposed to be. Yeah, that's where it's supposed to be. That could be Enceladus. Here, let me show you Stellarium again. Okay, so Rhea, Enceladus, Dione, Tethys, Titan, or no, Titan's off the edge a little bit up there. And let's go back to the telescope. Okay, so what do you think? Rhea, I think that could be Enceladus there. Enceladus is really interesting because it's made mostly of ice, or ice and rock. But because of the gravitational interactions with Saturn, there are areas, there are volumes of liquid water underneath the surface. And when the moon is kind of stretched and pulled by the gravity of Saturn, it leads to geysers of ice that come out mostly from the southern pole of Enceladus. This is a big discovery of the Cassini mission about 10 years or so ago. And that ice is actually part of why the rings of Saturn are so bright, because the rings of Saturn are coated in ice that makes them very, very reflective. And in fact, Enceladus may be one of the places in the solar system where there could be simple life as we know it, simple life in that water underneath the surface, because the components that you need for life as we know it, liquid water, organic materials, a source of energy, it's all there. So I think that's it. I think we got Enceladus. You know what? I'm going to take some video here and save that to analyze later. And I'll post my best images on in the YouTube comments in the video description once I've uploaded the stream. Yeah, that looks pretty good. Nice to see the moons, even if the the atmosphere is not really steady enough to see a lot of detail in the rings. Titan is also a very interesting moon. Let's see, where's Titan? Yeah, that's Titan up there. Titan is the biggest moon in the solar system, and it has a very thick atmosphere that's made of methane and nitrogen and, of course, carbon dioxide. And it's one of the places in the solar system where we've landed a robot. Right? How many places have we landed robots? Mars, there are a lot of robots on Mars. Venus, there are a couple of robots on Venus. There's an asteroid, the Eros, the near-Earth asteroid Eros. The asteroid Bennu just recently landed on. Am I getting? I think that's almost it. And then the moon Titan, Saturn's moon Titan. The Huygens lander landed there in 2004. And it's very interesting. It's got a thick atmosphere. It's got a very cold surface and atmosphere. And it actually has liquid methane lakes and rivers. So there's interesting hydrology happening on Titan. Let's see if there are other questions here. What telescope are you using? I'm using a 12-inch Meade Schmidt-Cassegrain telescope. You can't see it very well from the point of view of the camera because it's on the other side of the counterweights. But it's fairly basic amateur grade 12-inch Schmidt-Cassegrain reflecting telescope. Let's see. I've read that it's actually quite warm down near the core. Well, it's warm enough for liquid water, so quite warm. Yeah, that depends. I mean, it's geologically active in a sense, but it's not a kind of a magma lava geology like inside the Earth. It's kind of a cryo geyser situation, and it's the pressure and the heat that drives the geysers. I haven't seen recently what the predicted temperature is. Okay, why don't we go take a look at the moon tonight too, before we run out of time. And I think that's when I'll talk about what's up in the sky. And if anyone has any questions about what's up in the sky this week, or what are some interesting astronomy events that are coming up, I'd be happy to take questions then. I'm starting to feel pessimistic about looking for that asteroid flyby, that one that 30-meter one that's over towards the moon, just because it's getting more cloudy over in that direction. But here, let's move to the moon. So I won't bother to switch to the telescope control for you here. I'll just go ahead and move to the moon. Moon should be easy to find. Here we go. And in this camera, you'll see the telescope moving over there. Maybe I'll enlarge that view so that you can see that a little bit more clearly. Right, so here comes the telescope. Because the moon's way over in the east, you're going to end up seeing a little bit of the front of the telescope. Yeah, so okay, so let's bring up the video from the telescope. And let's do some exposure adjustment here. It's already it's pushed way so down. It's pushed down the exposure. It's catching up. Here we go. Here comes the moon. Nice bright full moon. I'm going to turn down the saturation because I don't care about the color so much here. There's the super bright full moon. Let's actually move down to kind of the southern pole of the moon. I go to the telescope controls here. Move a little bit. You can see the crater Tycho. This very bright crater. I can see some clouds coming by. Because it's not an exactly full moon, I might see a little bit of shadow at one of the edges. Move over this way a bit. Oh, I see a comment about Enceladus. Oh, so you looked it up. Enceladus is 200F. Wow, near the core, according to NASA. Wow. Okay, that's pretty cool. That's impressive, and that would certainly drive a lot of pressure for the geysers. I believe it. Oh, where did the moon go? Oh, clouds coming by. That's what's happened. I keep moving over to this side of the moon. You know, actually, the shadows would be potentially on the west limb, the west edge of the moon. So I'm going to actually move over to that side. It does look pretty cool when the clouds are moving by like that, though. And we could actually even zoom in, you know, on some of these different parts. And yeah, the atmosphere is just not very steady tonight, so it does look good, but not going to see a lot of features there. That part that's coming out, oops, that part that's coming out over there is a little bit overexposed. Yeah, I don't really see, maybe if we go up there, we'll see some shadow. The telescope, this camera on this telescope can't see the whole moon at once. It doesn't have quite enough. It's a little bit like a zoom lens. It doesn't have quite enough field of view to see the whole moon. I think I can see a little bit of shadow up there. If you're a dedicated moon watcher, there's a phenomenon that you can look for that's kind of interesting, which is the libration of the moon, where the moon, as it goes around the Earth, it's not in a perfectly circular orbit, and so it speeds up and slows down. But the moon is also rotating to always keep one side towards the Earth, right? You look at the moon and you always see the same features. You see the Maria and the man on the moon effect and so forth. So you think, oh, the moon isn't rotating relative to us, but it is rotating relative to the distant stars. It's rotating to keep one side towards us as it orbits. But it's rotating at a constant speed, you know, just like a gyroscope or a top will spin at a constant speed. But the orbit is going faster and slower. So sometimes you see a little bit of the front of the moon, and sometimes you see a little bit of the back of the moon, and you can see a little bit more than half of the globe of the moon, sort of depending on where it is in its orbit. I see a little bit of shadow up here. The full moon, I think, is less sort of aesthetically dramatic. Yeah, I see some shadow and some craters up there. Let's zoom in on that. Yeah, there's some shadow up there at that edge. Yeah, so we're seeing some places that's kind of interesting where here's a crater right here, and you can kind of see the shadow of kind of the front edge of the crater, if you like, and then the sun is shining on kind of the back rim of the crater. It definitely gives you a little bit of a three-dimensional appreciation, appreciation for the three-dimensional shape of the moon. A student from Astro 155. How much would it cost? How easy would it be to get an amateur telescope, computer software set up at home? Yeah, there's a lot of good clouds. It's really amazing the equipment that you can get as an amateur astronomer now, and do really advanced projects, do really amazing astrophotography. You don't have to spend a lot of money to get a really nice setup. You can spend a lot of money, and if you're doing some advanced projects, you might want to. But I have this little telescope that's a 3.5-inch telescope. It's about $200. I got a used digital SLR camera online for about $200, and that can get you started in astrophotography, taking images of the moon, taking images of the planets, taking images of brighter star clusters and things like that. And so, you can get into this for sort of $500. If you then want computer-controlled cameras and computer-controlled telescope mounts, maybe it's going to cost you like $1,000 to $2,000. And then if you want sort of a semi-professional setup like this, or like the telescope that's in the dome over here, yeah, then it's tens or hundreds of thousands of dollars. But you don't need that to get started, and you don't even need that to do a lot of really fun projects. So this earlier this summer, I was doing the live stream from my backyard with this telescope and an SLR camera, and getting nice views of star clusters and the moon and Venus and so forth. I'd like to make some YouTube videos about getting started in astrophotography and using computers and cameras and so forth. So eventually I'll get around to that. There are some other good YouTube channels out there that amateurs are sharing what they're learning about doing astrophotography and using telescopes and so forth. I think they tend to spend too much money. You don't have to spend that much money to get really nice results getting started in astronomy, getting started in astrophotography, and even getting started in doing observational astronomy, where you're doing quantitative measurements of the universe to learn about the astrophysics of the universe. Okay, it's getting more cloudy, so I don't think I'm going to get to see the asteroid. Here, I'll show you what the moon's look. I'll share a view of what the moon's looking like right now. So panning back across there, you can see the moon up there, and the clouds are getting thicker. Some of them are quite dark. You could see that through the telescope. If I pan back over here, you can see downtown New Haven over there. And if I pan up a little bit, you can see Jupiter and Saturn right there. And I move over here. There would be some bright stars over in this part of the sky, but it's a little bit too cloudy. Basically, you're seeing light pollution over there. And then I have the 90 millimeter refractor set up right there, and there you can see the 12-inch pointing at the moon right now. Okay, last thing I'll do before I sign off tonight is talk a little bit about what's up in the sky this week and sort of what's in the sky this season. So let me switch over to Stellarium again. And I'm just going to zoom back out from Saturn and set the time to now. So here's what the sky is looking like right now. And earlier this summer, at the beginning of the summer and the late spring, we're looking at what I think of as the spring constellations like Leo and Virgo, and looking at some of those galaxies over there. I'll show you the constellations that are up right now. Virgo's down here. Libra, Scorpio, Sagittarius would be the next ones along the zodiac. And you can see there's Jupiter and Saturn and the moon aligned with the ecliptic. The ecliptic, of course, is the plane of the Earth's orbit projected up into space. And because all of the planets orbit in nearly the same plane, you always see the sun and the moon and the naked eye planets close to that. So what are some interesting constellations that I can point out? So I mentioned the summer triangle before, so here's the summer triangle right here. And whereas the spring, sort of April, May, is a good time to look at the Virgo cluster and the galaxies that are in the Big Dipper and so forth, the summer is a really nice time to look at the Milky Way, right? So I'm going to turn off light pollution here so that I can really see the Milky Way there across the sky, across the screen. So there's the center of the Milky Way over in that direction, right next to the constellation of Sagittarius. Sagittarius is easy to recognize because of the shape like a teapot, right? There's the lid, there's the spout, there's the handle, and it just gets above the trees here from the observing deck. So I could see it on Sunday night when it was really clear, and it's a little bit sort of down and below where Jupiter is. So Jupiter is right up there, and Sagittarius would be kind of, if it were clear, would be getting into that tree over there. The next constellations on the zodiac are pretty faint, right? Capricorn, Aquarius, Pisces. None of the stars in those constellations are very bright, so they're hard to see. But if you kind of look along the Milky Way, the summer triangle is very bright, and the constellations that those stars are in are easy to recognize and bright. Cygnus the Swan is a beautiful constellation. you can see along there. And then if you keep going along the Milky Way, you see Cassiopeia, which I can't see right now. It's getting too cloudy. Cassiopeia is the W constellation, right? So it's kind of the zigzag of 5 stars, 5 bright stars. You can see them even in places where you have a lot of light pollution. And then looking over here to the east, this is the sky right now around 9:20. Looking over to the east, we're starting to see the square of Pegasus coming up. So if it were clear, there's the moon right there. The square of Pegasus would be right above the 8-inch refractor dome, right about there. And 4 bright stars in kind of a diamond or a square shape, so fairly easy to find and recognize. Once you find the square of Pegasus, if it's clear out, you can potentially find Andromeda and find the Andromeda galaxy. So if you look at this star, that's the one furthest to the left when you're facing east. That's a star that's shared by both Pegasus and Andromeda. I think technically it's in Pegasus. And if you count 1, 2, 3 bright stars over, and then 1, 2, 3 bright stars up, if you look with binoculars, or if it's really dark where you are, you'll see the Andromeda galaxy right next to that star. So there's the Andromeda galaxy. Closest big galaxy to the Milky Way, about 2.5 million light years away. It's heading towards us at 300 kilometers per second. So in a few billion years, we're going to merge with this galaxy, or at least it's going to get very big and bright in the sky. Maybe we'll have a near miss, but we're probably going to end up having a merger with this big spiral galaxy. We can see it. You can't really see it with the naked eye here in New Haven at the observatory with the light pollution, but we can easily see it with binoculars, and it's nice to look at with one of the 8-inch or the 12-inch Dobsonian telescope is a nice telescope to use to look at that. And then the Big Dipper is always opposite from the North Star relative to Cassiopeia. So if Cassiopeia is high in the sky, kind of in the northern sky, the Big Dipper is probably really low in the sky. Now, here at our latitude, the Big Dipper never really goes below the horizon, but this time of year, kind of in the fall to late winter, we basically lose the Big Dipper down into the trees at sort of sunset to midnight when we're typically out looking at the sky. Okay, I think I'm going to stop there. So if you do get a clear night this week, I think the forecast is for a decent amount of rain and clouds this week, but it may clear up closer to the weekend, like Friday, Saturday, Sunday, it may clear up. So if you do get a clear night this week, go out, look for Jupiter and Saturn. By the weekend, the moon will have moved off into the morning sky as it orbits around the Earth, of course. But Jupiter and Saturn are going to be up there all fall and looking great, both with the naked eye and through small telescopes or big telescopes. And look for the summer triangle, which is pretty much overhead at sunset this time of year at our latitude. And if you happen to be someplace where the sky is dark, if you're outside the city, look for the center of the Milky Way. Look for the Milky Way going across the sky almost directly overhead from the southeast, from the northeast to the southwest, basically. I think this is one of the best times to look for the Milky Way. All right, let's see if there are any other questions. While I'm waiting for questions, I'll just talk about a little bit about some of the other projects that we've been working on. With converting the observatory to doing a lot of remote observing, like we did with our summer program for high school students, and like we're doing this fall for our labs for intro astronomy classes, we've been updating the telescope to allow it to be controlled remotely over the internet. That's mainly actually required us to update the dome so that you can rotate and open and close the dome remotely, which will be interesting. Actually, we'll be able to do some automated observing perhaps, which I think may lead to some interesting projects. We've been working on some sort of maintenance and updates of the inside of the building. I really don't think we're going to be able to open the planetarium theater either to Yale students or to the public really until the pandemic is over, because it's not a very well ventilated space. I mean, there's vents behind the dome that push air into the planetarium. So it's a positive pressure space, and then the air goes out. But you want to be, if you're going to be around other people, you want to be outside as much as you can. Even with masks and even having people sit far apart, I don't think we're going to be able to do planetarium shows this fall or even into the early spring. But the observing deck here is outside, and our telescopes aren't quite 6 feet apart, but we could have telescopes every other pier, and we could put some telescopes out on the lawn. And so I think probably before the end of the year, we'll be able to have visitors for observing on clear nights. So that may come back to Tuesday nights before the end of the year. If the infection rates in Connecticut stay down, and the infection rates at Yale stay down, so that the authorities are willing to open up the campus a little bit. And we'll wear masks, and we'll stay away from each other, and we'll swab down the telescopes with alcohol to try and minimize any risks. And I think we may be able to do some of that this fall. Okay. Well, thanks for your attention. It's been a lot of fun. I'm Michael Faison, as I said. If anyone has any questions for me, you're welcome to email me. My email is michael.faison, Faison, @yale.edu. And the Leitner Observatory has a website, Leitner Observatory, Leitner observatory.yale.edu. If you go to the website, you can see our Twitter feed, you can see the weather predictions, you can see any upcoming events will be announced there. And I expect I'll be here Tuesday night next week doing a live stream. Might start a little bit earlier because we're getting closer to the fall equinox. It's getting darker a little bit earlier, so we could start a little bit earlier. And keep an eye on Jupiter and Saturn this fall when it's clear, and look at some other interesting objects when it's clear in the fall. Some of my favorite fall and winter objects. And like I did over the summer, I'll have some other special events for the live stream, some discussions with astronomers, some special planetarium shows and demos and things like that. So when it's cloudy, I'll have some more of that queued up, ready to go. Let's see. Last questions before I sign off. Has Yale ever considered trying to get an observatory built on East Rock, West Rock? Well, those are city parks. Oh, I just saw a meteor. I just saw a nice meteor over in the southeast. That's another nice thing about getting to be outside and looking at the skies, that you get to see meteors. We actually have an all-sky up to monitor the weather, and so we'll see meteors on the all-sky camera. But anyway, to answer the question about East Rock or West Rock, those are city parks. Those belong to the city of New Haven and the people of New Haven. Yale's not going to take part of that to build an observatory. You generally want observatories, far from a city, up high as possible. Until recently, Yale had an observatory at Bethany, the Bethany Observatory, and the Astronomical Society of New Haven has public events out there using some of the telescopes out there. That was actually a research observatory for Yale in the 50s, 60s, 70s, and then it became an outreach center. We're probably going to have a remote telescope set up in northwestern Connecticut. We've been talking to Hotchkiss School about setting up an observatory out there, someplace where the sky is dark, and there's some projects we'd like to do using a remote automated telescope. But these are teaching projects. For the projects we're doing research, we're using telescopes in Chile and Hawaii and Australia, and places where the sky is really dark and you're on top of a mountain and they're really, really big telescopes. So that's mainly what the Yale astronomers are using for research. Let's see, how do I get better images through my telescope? Do I have to upgrade the eyepiece, or is it the telescope itself? It depends. It could be your observing location. It could be the telescope. It could be the eyepieces. I think one thing that amateur astronomers, when they're getting started, do is get eyepieces with too high magnification. So, for example, on this telescope right here, the refractor that I have, it's a 600 millimeter focal length telescope, and the eyepiece that I mainly use with it is a 26 millimeter focal length eyepiece. So the magnification is always the focal length of the lens of the objective divided by the eyepiece. So 600 divided by 26, 30 something x magnification. That's much lower magnification than you'd think you'd get with a good telescope. I want 1,000 x magnification. But I found that the longer focal length eyepieces give you a better view, and if you have a really steady atmosphere, yes, you can go to higher magnification. But that's one of the main things I would recommend people do. When you buy an inexpensive telescope, one of the first things you can do is upgrade the eyepieces. You can buy the Orion Expanse eyepieces are really good, and buy like 20 millimeter, 30 millimeter. They get really expensive as they get really long and low power and wide field. But it's sort of good to have a 9 millimeter, a 20 millimeter, and a 32 millimeter eyepiece to sort of have a range of magnifications and zoom factors. And it could be, Richard, it could be a couple of different things affecting your view. So you could email me if you'd like. I'm happy to give you more specific answers. All right. So with that, I am definitely going to sign off. So I wish everyone well. I wish everyone clear skies. See you next time.